Hello everyone, today we are going to learn about what are raising and lowering operators. We will be finding these operators by the concept of quantum harmonic oscillator using operator method. So let's go. We all do know about the concept of quantum harmonic oscillator. We shall straight dig into deriving the raising and lowering operators. Here we will be solving for energy eigenvalues of linear quantum harmonic oscillator. This method is based on the basic commutation relation, which is xp equals to IH cross, where x and p are the coordinate and momentum operators respectively. Now the strategy is to find these operators, that is raising and lowering operators. We will solve Hamiltonian of linear harmonic oscillator, and it is given as H equals to 1 by 2m p square plus 1 by 2 m omega square x square. It is convenient to introduce new operators A and A dagger, and which is defined by A equals to under root m omega by 2 h cross x plus I under root 1 by 2 m h cross omega p, and A dagger is further given as Hermitian adjoint of the operator A. The value of operator A and A dagger is obtained by solving the Hamiltonian for harmonic oscillator. We have seen the Hamiltonian of the harmonic oscillator as H equals to p square by 2m plus m omega square x square by 2, where p is the momentum operator, which is given by p equals to minus IH cross d by dx. Here, if we consider p as a number, we could factorize as p square plus m square omega square x square equals to minus ip plus m omega x into ip plus m omega x. After solving this, we get this value, and if we further solve this, we will get the value of operator A and A dagger as defined earlier. Now from equation A, in which we have defined the value of A and A dagger, now we will find the product of A dagger, which is given by H by H cross omega plus 1 by 2. Here H is the Hamiltonian, and in the same way we can find the product of A dagger A equals to H by H cross omega minus 1 by 2. From B and C, we can find the value of Hamiltonian, which is H equals to H cross omega by 2 A dagger plus A dagger A, and commutation of A dagger equals to 1. Therefore, the commutation of A and Hamiltonian H is given by H cross omega A. Here we can solve this as given on the screen, and similarly we can find the value of commutation A dagger H, which is equals to minus H cross omega A dagger. Now to obtain the energy levels of the oscillator, we have to calculate the matrix of Hamiltonian and diagonalize it. However, if we work in the energy representation in which the eigenvectors of H form the basis of space, the matrix of H would be diagonal, and which is given as the equation D. Here En is the energy eigenvalue of the n state. And now we shall calculate the matrix of product A dagger, and here it is given by En by h cross omega minus 1 by 2. Also, the matrix of A dagger A can also be written as this way, and from E and F we will get En by h cross omega minus 1 by 2 is greater or equal to 0, or it can be also written as En equals to, En greater than or equal to 1 by 2 h cross omega. Now consider the eigenvalue equation h ket n equals to En ket n. Operating from left by A, we get Ah ket n equals to En A ket n, but from above Ah equals to Ha plus h cross omega A, and therefore we have Ha ket n equals to this En minus h cross omega A ket n. That is, if ket n is an eigenvector of H with an eigenvalue of En, A and ket is also an eigenvector of H corresponding to an eigenvalue lowered by the value H cross omega. In similar way, we can also show that H A dagger ket n equals to En plus H omega H cross omega A dagger ket n. Here we can see that if we operate by A, the eigenvalue of energy is decreases by h cross omega, and if we operate by operator A dagger, it is increased by the factor h cross omega. That's why the operators A dagger and A are respectively known as raising and lowering operators. Now to find the minimum eigenvalue of energy, we consider this E0, denoting the ground state eigengate corresponding to the minimum eigenvalue E0 by ket 0. We have HA ket 0 equals to E0 minus h cross omega A ket 0. As En greater than or equal to h cross omega, this equation is possible only if A ket 0 equals to 0 or A dagger A ket 0 equals to 0. In other words, we have here only put the value of A, and that we get as E0 by h cross omega minus 1 by 2 ket 0 equals to 0. As ket 0 is cannot be equals to 0, here we get E0 minus 1 by 2 h cross omega equals to 0, or E0 equals to 1 by 2 h omega cross. Here we can see that the minimum energy of the quantum harmonic oscillator is not 0, and instead it is 1 by 2 h cross omega. Repeated operation by A dagger raises the eigenvalue every time by h cross omega, and the repeated operation by operator A lowers the eigenvalue every time by h cross omega. That's why here we get the energy eigenvalue of nth quantum state as En equals to n plus 1 by 2 h cross omega, where n can be equals to 0, 1, 2 and so on. Here we can see the diagram of the energy state from 0th level up to nth level. Here we can see that the 0th level it is not equals to 0, instead it is h cross omega by 2, and it is further increased by h cross omega. So here we can conclude that according to equation H, which is the operator A annihilates the quantum energy by H cross omega, and therefore it is referred to as annihilation or destruction operator, which is lowering operator, as we have seen earlier. Similarly, the operator A dagger creates quantum energy by factor H cross omega, which is given in the equation I, and therefore it is called as creation operator, that is raising operator. This A and A dagger operator plays important role in the quantum theory of electromagnetic field. Thank you.